Our objective today, I can write and solve proportions. Now, if you don't know what a proportion is, we've seen them before already, and we've done them already, in fact, when we reduce fractions, okay? So for example, in the past, we may have seen something like 2/4, and then in the past as well, we'd say, and I know we use a calculator now, but we'd say divide these both by 2, and that gives us something that's equal in value but looks different. That'd be something like 1/2 right here. That's all a proportion is. It's just two fractions, two or more fractions, that have exactly the same value. But, like I was saying, it is possible that they can be shown differently. Okay, so like I was saying, we have done this before, right? Yeah. We've looked at two fractions that have exactly the same value, but when we say they look different, in the past we were doing something like simplifying the fraction. Or what we've done in the past is we forced denominators to match in order for us to add or subtract fractions as well. So they need to be in fraction form, usually anyways. So I like to look at it like this, and I'm not sure if I've done that with this class yet. Well, let's see if I can do. We'll pretend like I'm a really good artist. And we'll pretend like this is a sandwich, okay? So if I cut this sandwich in half, like this, and let's say that this is your half, okay? You get this half, and this half is for me. Now we're going to focus on you today, okay? You got one piece out of two pieces, okay? Now it is a sandwich, and you get one piece out of the two, because I want my piece, because I like sandwiches. Well, most sandwiches, okay? But what happens is if we take this same sandwich, let's say that we split those two parts, those two pieces, into two extra pieces, right? Now, here's the thing. We cut it into 4 pieces, but now we would say that you get 2 of the pieces. Now, even just looking at the picture, do you get a different amount of sandwich? You don't. You get the same amount of sandwich. Yeah. Right? Because you still get these 2 pieces right here, and then I get these 2 pieces. All that changed was the sizes and how many pieces we get. Okay, of the 4 pieces, right, because they're smaller pieces, 2 pieces of sandwich would be bigger than the 4 pieces. But now we made them 4th size pieces, but now you get these 2 pieces, and then I get these 2 pieces. You get 2 pieces out of 4 pieces. Okay, so because you're getting exactly the same amount of sandwich, we can put an equal sign between these, and we can say that they're equivalent fractions. Okay, in fact, what we can do is we can expand this even further and say, look, if I cut this into 8 pieces, right? So if I cut these into halves, like this, yeah, now you get 4 of the 8 pieces. But, once again, in fact, I'll kind of highlight that here. So this is your half of the sandwich. But now it's 4 pieces out of 8 pieces, and I get my 4 pieces too. So 4 pieces out of 8 is the same as 2 out of 4, which is the same as 1 out of 2. Okay, but these, all 3 of these, and we could do more, but all 3 of these would be considered equivalent fractions, so we can call them proportional. We can say that these fractions are proportional. Now, one thing they're going to do, like we said in the objectives, we're going to write and solve proportions. What they're going to do is they're going to say, look, now you got to figure out what this value is right here, even though they're only going to give us something like this part. They're going to say 2 out of 4 equals something out of 2. Right? Now you're going to take the 4 pieces, and instead you're going to get rid of, I guess what would be these 2 cuts, like this. No, you get rid of these 3, right? Now you have 2 pieces, but like we saw before, you get 1 out of the 2 pieces, okay? Now we'll give you strategies to do that. In fact, we'll look at 4 different strategies. 2 of them are not used so much by students, but the other 2 are used quite often by students. So this one's saying we got 8 over 12. It's saying, is this statement true? Does 8 over 12 equal 15 over 21? So I'm going to put a question mark over the equal sign because I don't know if this is a true statement. So what this means is that the overall value of this left side of the equal sign, which is 8/12, or 8 divided by 12, it has to have exactly the same value as 15 over 21. Now there's lots of different ways you can do this. My preferred way is the calculator method. I think I'm going to end up doing this twice. So the first way is actually to change both of these into decimals. So I'm going to take this 8 over 12, and all I'm going to do is type into my calculator 8 divided by 12. Now when I do that in my calculator, I got this pretty ugly decimal. How many sixes do I got? A lot of them. Something like this, okay? And for the 15 over 21, I'll put this above because I ran out of space, but I got this other ugly decimal, 0.714, 2857, 14, okay? Now, having changed these both into decimals, we can compare the decimals directly. Remember, they need to be exactly the same. This question mark and the equal sign means they need to be exactly the same. Looking at the two decimals we have, are they exactly the same? So just knowing that much right there, seeing that we have a 0.6, for example, and then a 0.7, means that they are not the same. So that means we would say that, is the statement true up here? We're going to say no. Now, that is one way to do it. Okay, now I'm still using the calculator because I just typed in 8 divided by 12 to get this decimal, which is prettier than this one, but they're still, in my opinion, ugly. And then we typed in 15 divided by 21 to get this decimal. What we can do is we can go to the calculator, and if we push the double arrow button for both of these, then it'll tell us the simplified fraction of both as well. Okay, so for example, the 8 over 12 came out, and the calculator is simplifying it as far as it can go. So if it gives you something different, then you know that they're not exactly the same as well. So 8 over 12 came out as 2/3. 15 over 21, this one came out as 5 over 7. Now, of course, if it's doing it this way on the calculator, changing these both into fractions shows that they are not the same. So if you put an equal sign, you got to put a slash through it to show that they are not the same instead. Okay? All right, here we go. Now we're dealing with decimals, right? I got 2/10 over 3/10 on the left. And I got 1 and 2/10 over 1 and 8/10 here on the left, on the right, left and right. There we go. The statement says, is the statement true? So I'm going to put my question mark over the equal sign because we don't know if they actually are equal. That may be a false statement. Who knows? But try it out. See if you can do it. Then we'll go over it. So when I put these into my calculator, 0.2 divided by 0.3, I got that. It's the same decimal from the last one, 0.66, bunch of sixes, and then a 7. And then I did this one over here, 1.2 over 1.8. And as it turns out, I got the exact same decimal. 1, 2, 3, 4, 5, 6, 7, 7. Okay? Now, of course, these are exactly the same. They're the exact same decimals. And that's good. That's what we want to see. If by chance you change these back into a fraction, then the red one gave you 2/3. But additionally, the green one also gave you 2/3. So again, however you want to look at it, these are both equivalent to each other. They're exactly the same value, which means that, is the statement true? Yes. Okay, so this equal sign, like we saw in the last problem, it came out false. This time it comes out true. Okay, so what they're going to do now is they're going to give us unknown values in proportions, like we said they would. And there's 4 different methods to use. Now, scale factors is a method that we have used already. It's when we either simplify a fraction or when we scale a fraction up in order to force denominators to match, okay? So if you look at a scale factor, so let's scale factor. For example, if you started with, let's go back to 2/3 again. Okay, scale factor, if you wanted to use a scale factor, So let's say that the other fraction, let's say that the numerator is, let's say it's 10. Something fairly easy to work with like this, okay? But we don't know, let's say that they don't give us the denominator, like on this one, okay? What you can do is, if this, because this comes out pretty nice, you may know already that 2 times 5 is 10, okay? But we know that if you multiply the numerator by 5, like I've just done, then you must also multiply the denominator by 5 as well, and that would give you a missing denominator of 15. This is a scale factor. Now, the scale factors that I used was with multiplication, but like we've seen with simplification as well, you can divide as well. Just remember, if you multiply the top or bottom by a certain value, you have to do the same to the other. Multiplication or division. You cannot scale factors. Remember, scale factors is related to multiplication. So addition and subtraction do not apply. So I bring that up because it is something that we have done already, okay? Now, if you like that method, that's great. But you'll see that there's going to be some cases where you're like, I don't know what I got to multiply or divide by in order to make that other value. Then you may find that some of the other methods are a little bit more helpful for you, and that's okay too. Okay, so principles of equality is where whatever you do to one side of the equal sign, you must do to the other side as well. So for example, if over here, let's say we got a proportion, right? So proportion will always start with 2 fraction lines and an equal sign, just like we've seen in the previous slides, okay? So I'm just setting up a proportion. And let's say that we start with, let's make it like x over, I don't know, 4. And we'll do this as 3 over 5, something like this, okay? Now, a principle of equality will say, whatever you do to one side of the equal sign, you must do to the other side of the equal sign in order to solve it. So right here, if I have divide by 4, x divided by 4, and I would like to solve for x, which I do, then I would have to multiply the left side by 4 in order to make that a phantom 1. But if I do that to one side, I must do it to the other side. Now, don't worry about what the answer is here. Well, what the heck? X would be 12 over 5. Don't worry about how we get that, okay? But you would just put that in the calculator, 3/5 times 4, and it would give you 12 over 5, and that's fine. Okay, but my point here is that you can use principles of equality. If you do something to one side, like I did here, then you just must do it to the other side. That's it. Now, those are the 2 methods that are rarely used in this class. But I like to show them because we have seen both before. Cross multiplication is generally the most used one. Although once I show fish method, there's some students that kind of flip between the two. They'll use both, depending on the situation, okay? So, cross multiplication is something that you've seen before. So, cross multiplication is where you're going to take a proportion like this one, all right? Again, a proportion, 2 fractions that are exactly the same, which is why we have the equal sign in between here. Okay, so if we have, again, there should be some kind of unknown in there. Usually they'll use an x, so let's put the x right there, just because. All right, and we'll say we got 7 over 4, and what the heck, we'll make this 21. What the heck? Okay, so cross multiplication says that if you take a cross, now we're talking diagonally from each other. Now notice that that green line that I've put in there points to the 7 and the x. That means you're going to multiply those, which is why it's called cross multiplication. You crossed over the equal sign and multiplied the 2 together. What happens is that it's exactly the same as taking the other cross and multiplying those as well. So then you'd have 4 times 21. Now, of course, you can solve this, and if you do, you should get something like x equals 12. I skipped some steps because we're going to show more examples. Okay, but this is the main, if you can get here, then you're going to have to use principles of equality anyways, because you'd have to divide both sides by 7. And then you just put that in the calculator, you get x is 12, okay? There we go, there's the steps, yep. I am very partial to fish method. Not just because I like to eat fish and catch them. I like to catch and eat fish. I like to kill fish. So, this is not what you think, maybe. Maybe you've seen this before, okay? So let's put some values in here. Again, let's put an X right there, because it doesn't matter where it is, okay? So, fish method, you're gonna make a fish, and let's put some values in here, right? So we'll do 50 and we'll do I don't know, 80. Yeah, 80's good. Now, again, this proportion that I've set up here, 5 over x equals 50 over 80, yes, scale factors would work. It would work very nice. But I'm doing this to emphasize fish method. So you may know what x is right now without doing fish method. And if you do, that's okay. But I'm going to show fish method. Fish method, whenever you use it, if you want to use it. So you see in the proportion, you've got 1, 2, 3, 4 values. You pretty much have 4 spots to work with. You got the 5, the x, the 50, and the 80, okay? So that means you got 4 values to work with in fish method. Now, the difference between fish method and cross multiplication is this will do cross multiplication, but in 1 step instead of 2. Okay? The operations are always multiplication, then division, and then you get something that equals, okay? What we want it to equal always is whatever the variable is, in this case, x. Okay, so this is the setup. You got multiply, divide, equals x, or whatever the variable is. Okay, so fish method, and you'll forgive my artistic ability here, please. So you always start with x, and you end with x, no matter where it is. Okay, first, create the tail of the fish. And since this is not our class, this is math class, it's a math tail, fish tail, okay? So I started the x right here, and then I go straight up here, boom. That's the first value that goes into my set, 5. Now that's the tail of my fish. Some of you know where this is going, I think. I'm going to cross down here to the 80. This is making the body of the fish. There's 80. Notice I started at x. This is where I will end. I go to 5 first. I put 5 in first. I come down here to the 80. I put that in second. And then I'm going to bring this back up to the 50, which is, you see I've created the head of the fish there. Well, maybe not because it's a math fish. It's not very pretty, but it's, I think it's great. Okay, so I put in a 50, and then you see, remember we started at x, we got to end at x as well, okay? So if you were to plug this into your calculator, 5 times 80 divided by 50, you would get the answer directly as x equals 8, and you'd be done. Now this fish, right, this fish started with the x on the bottom left. Okay, just understand that in some cases what you'll have is you'll have an x, let's say on the top right, like this one, okay? And if you do, remember you're going to create the tail of the fish like this, then you're going to come up here, then you're going to come down here, and you're going to finish off where you start, always with the letter, the variable, the x, whatever letter it is, okay? So some fishes, like you see this one, it faces to the right, the face is to the right. This one, sometimes you'll see that it's faced to the left. I like this fish method, but not all students do, and that's okay too. Okay, like this one, all right? So solve this proportion with specifically principles of equality. Okay, so a principle of equality, yeah, let's set our x in there just so we can kind of treat it like an equation, which is when we use principles of equality. But if I were to look at this, I would take both sides, because what I want here, since I'm looking at it like an equation, which is why we're using principles of equality, I would like this to be an x, which is really just a phantom 1x, like this. Okay, so right now what I have is an x divided by 3.2. But what I really want is just a phantom 1x. So what I'm going to do is I'm going to take that divide by 3.2 and multiply instead. Now again, I've done that on the right side, multiplied by 3.2. But since I've done it on the right, I must also do it to the left. Okay, 3.2 divided by 3.2 is 1, and that's where the 1 comes from. And the rest of this I can just plug into the calculator. 3.2 times 0.3 over 0.8. And when you do that, you're going to get 1.2. You may get, let's see, 6/5, maybe, something like that. if you want the fraction. But I put this in as division, so I use this as a division sign. On my calculator, it gives me the decimal. Boom. This one, we're going to use scale factors, okay? Now, factor generally says that we're going to be using multiplication, but on this one, as it turns out, we're going to have to use division. So what we see here is you got something over 8 needs to equal 4 over 24, okay? Now, scale factors are nice when values are multiples of each other, such as 8 and 24. Okay, now they need to be directly across from each other, straight across, not diagonal, okay? So what I'm doing is I can see that the unknown is here on the left. So the 24, see how our unknown is, it's here on the left, okay? Which means that for both of these, we're going to be going to the left. Okay, so the question here is, how do you make it 24 and 8? Now, since it's going down, right, you start with 24, you end with 8. This means that you have to be using an operation that will lower the value. And since the only operation that we can choose that will lower the value is division, we must choose it. You can't use subtraction here. But if you divide on the bottom, like we're showing there, you must also divide on the top. What do you divide 24 by in order to get 8? It'd be 3. So on the top, you'd have to do 4 divided by 3 as well.
So that's 12.
Now, 24 divided by 3 is 8, but 4 divided by 3, 4 divided by 3, you just put this in the calculator. Now, we don't want the decimal here because it's going to look, it's a repeating decimal. What we're going to do is we're going to write this as a 4/3, and we'll keep this as a complex fraction. But the unknown value is the 4/3. Okay, now this is the method that I used with scale factors on this one. But again, if you were like, you know what, I really just want to use fish method or cross multiplication, you still could have done that. I didn't, because it said use scale factors. What the heck? But on this one, we'll use cross multiplication on this one, okay? Now there's fractions in the fractions, so these are complex fractions. But take a minute, see if you can figure out what that value of x is, and then we'll go over it. So on this one, cross multiplication, so whatever we get from the multiplication should still be equivalent, okay? So I would start first with this 4/5 times 6 here. And in fact, I'll show the work here. So 4/5 times 6. You don't necessarily need to show this, because what we're going to do is we're just going to put this in the calculator. When you multiply these two, you're going to get 24/5. Okay? Now, you may have gotten 4.8 as well. I don't really care if it's the decimal or fraction. 24/5 or 4.8, whatever. Now, we're going to do the other cross multiplication. Now, that's showing as x times 2/5. But in order to make this look like something that we've done before, I'm just going to kind of switch the order there, which is the commutative property of multiplication, and make it 2/5 x. So what we have now is an equation right here that we must solve. And since we've solved equations with fractions before, I'm just going to use the same method. And this will require principles of equality now. So setting up my principles of equality, what I would like out of this is a 1x, not what I have now in purple in the 2/5 x. So how do you make a 2/5 1? You simply take it and divide it by itself. So on the other side, we got 24/5, but I'm going to have to divide that also by 2/5. So on my calculator, I put in 24/5, and then I divide that by 2/5, and that will give me 12. Okay, so on the right side there, we made that a 1. Anything divided by itself is a 1, which is where this one comes from, and that's what we wanted. So x is 12. Now, if you were to put this in the calculator, 4/5 divided by 12, and you put 2/5 divided by 6, you'd get something like 1/15 for both, but they will be exactly the same, which means that we have, in fact, found the solution to the equation that we started with. So let's go through this one. Let's do fish method on this one. Now, fish method, of course, has 4 values. 1, 2, 3, 4. Every proportion will have 4 values. And we're going to multiply and divide. I need a better division sign than that. Divide and equals. And we should always get it to equal the x, no matter what. Now, I've got the x there. We can wait till later to do it as well. It's up to you. But you should always end where you start. And you should always start with the x, or whatever variable it is. So I start here with the x. Now I'm going to make the tail of the fish. In fact, what I'll do is kind of separate this just a little bit. So I'm going to say the x, right? So I'm going to make the tail of the fish, which is just a straight up or down line. In this case, I've got to go up to get to the next value. That shows that I have reached the 1/4. So I put that into my first blank or spot or whatever you want to call it. And then I will cross down into the 8. Now that creates the body of the fish. So the second value is an 8. Then we'll swing this back up into the 2/4, which is the third value we run into, 2/4. And then you should always end where you start, which should be where the variable is. In this case, it's an x. Okay, so all I do is I go to my calculator and I put this in. That sounds right. Yep. X apparently equals 4. Now again, if you went back and typed in 1/4 over 4, you'd get 1/16. 2/4 over 8, that would simplify into 1/16 as well. Doesn't matter, we're going to get the same value either way for the x. We found the x, we did it. Now the question is just saying solve the proportion. So now this is where you really get to choose. I mean, you could have chosen before, but now just take a moment, try this one out, but just choose. You choose which method you want to use, and then we'll go over it. So if you look at this one and you're like, man, I don't know how to do a fish method, I would make this 8 over 1. Okay, so remember, if you ever see a number all by itself, just make it a fraction over 1, because anything divided by 1 is itself. So from here, we can do fish method, right? So we got 1, 2, 3, 4 values. Always multiply, divide, and then equals. Okay, so we're going to start at the x, because that's where we're going to end as well. And I guess we're going to go down here to the 2. Now that's the first value we run into is a 2. Then we would, so that's the tail of the fish, right? Now I'm going to create kind of the body part of the fish. And that brings me to the next value, which is an 8. Then I would swing this back down to make the head of the fish, and that brings me to my third value of 1. And then, of course, the last value we should end up at should always be the letter variable, in this case, x. X, yeah, there we go.
That's why I didn't do it that way.
So once again, we just put this into the calculator, and this will tell us what x does equal. If you put this in the calculator, you're going to get 16. Now, you could try this, right? You could say 8 equals, there's nothing really to do with the 8, but 16 divided by 2, does it equal 8? Yeah, it does. Which means, once again, we have found the solution. Okay, now keep in mind, like these numbers are fairly small, you know, like 1s and 2s and stuff. It doesn't matter how big the numbers get. Once you have two fractions that are equivalent or a value that equals a fraction, the fish method or whatever method you're using is applicable. Doesn't matter. Okay, so once again, we don't have to choose any specific method, but try this one out. And we'll go over it again. Okay, so by popular demand, fish method for blanks, multiply, divide, equals. Okay, so we've seen this, the x in this location already before. So we have the x here. We're going to make the tail of the fish. Again, it's just a straight up or down line. And the first number we encounter is a 4. Then we'll cross down to the 3 over 11. So that's the second value that we encounter, 3 over 11. Divided by, we'll make the head of the fish here. And that's the third value we encounter is the 8. And then we end where we start always with the x. That's it. Okay, so once again, we just put this in the calculator. 4 times 3 over 11 divided by 8. We get 3 over 22. That's it. Now again, if you were to type this in 4 over 3 over 22, let's see, you get 88 thirds. Yep, and if you do this one to 8 divided by 3 over 11, you get 88 thirds as well. So it will pass off as a solution, which is exactly what we want. We found the value that if you replace this x with, you get true statement with the equal sign. This one's a little different because now we have decimals and fractions, but that doesn't matter since we're using a calculator now. And if you're using fish method specifically, you just type in everything in, and then you're done. Okay, so try this one out, then we'll go over it. Okay, fish method it is. So once again, 4 slots. And again, the nice thing that I like about fish method is just that you just plug it into the calculator, boom, you're done. That's it, okay? So that's what we're going to stick with I'll start with the x. Again, I'll make the tail of the fish, which means in this case I've got to go up to the 3/5. Then I'll cross down to the 6.25. And again, even though we have a mixture between fractions and decimals on this one, it's no problem. Then we'll cross up, or we'll round that head up into the 7.5, and then finish that off at the x. So we type this into the calculator. If you got 0.5, that's good, because if you got 1/2, that's also good. These have exactly the same value. Just one is in the decimal notation and the other's in a fractional notation. That's it. In the objective, we say you need to be able to write and solve proportions. If you feel comfortable with fish method, we'll keep using it. But now we have to be able to write them from a word problem, okay? Now, they're going to give us usually some kind of rate. You could say it's a ratio as well, but they're going to give us two values to compare. But then they're going to give us two other values to compare. Why is that? It's because a proportion sets up as a fraction equal to another fraction. So these are fraction lines, not negative signs, okay? Now, the good news for us, since these are going to be word problems, is that as long as you know what two values you're comparing and which ones go together, then all you got to do is keep the labels where they are, wherever you put them, okay? So, for example, let's say we did dollars per hour, because that's a fairly common comparison. Dollars and hours, okay? You need to keep the dollars on the top and then the hours on the bottom, if you start that way. Now, do you have to set it up that way? Not when you're solving proportions, you do not. For example, you could have also set it up instead as hours and then dollars, hours on the top, dollars on the bottom. It's just wherever you put the label, it needs to stay there. So if you have dollars on the top, hours on the bottom, you don't want to switch it to hours on top, dollars on the bottom. What you've done right there is just jack the crap out of it, which we don't want you to do. So make sure you keep the labels where you put them in the beginning, and then keep them there. In fact, usually what I'll do is once I know what the labels are here, then I'll just make sure I put the labels there so I don't forget where they go. But you're going to fill these in. Of course, you're only going to fill in 3, and then since we like fish method, we'll use that to solve these. Some of the numbers are going to be fairly large. No problem. The calculator likes large numbers, and it loves to do them for us. And so I will let it do it for me. In Moab, the tax on a property assessed at $300,000 is $6,300. Write a proportion that you could use, whatever, to find the tax on a property assessed at $980,000. Okay, now this one, it's giving us two dollar values, but they're representing different things. Okay, so I'm going to set up my first fraction. In fact, I'll just set up the proportion, okay? Now, you'll probably say, well, yeah, but the labels are the same, right? Like, you got dollars, and then we're comparing them with other dollars. That's true, but the dollars come from something else, okay? For example, you have an assessed dollarage, if that's a word, at $300,000. And then the $6,300 is the tax. Okay, so they are different. So I should have made that red, shouldn't I? Okay, so I'm trying to color coordinate this. But again, you have the top. For me, the way that I have this set up now, you have an assessed value divided by a taxed value. You do not have to do it as assessed over tax. If you wanted to do tax over assessed, you could. And you will actually get the same exact value, which is the beauty of proportions. Again, you're going to get equivalent values as long as you do it right, and you can use whichever method you like. So the way that this sets up, right, we see that the assessed value was $300,000. Put a comma there. And then its tax for that $300,000 property was $6,300. Okay, so you can see I've got two of the three values that they've given us into my first fraction. Now the second fraction you have assessed over taxed dollars. Okay, so down here it says write a proportion that you could use to find a tax on a property assessed. So this is an assessed value It'd be weird if the tax was 980,000, but I guess they exist probably, right? But that's an assessed value, which is my numerator. So in my numerator, I'm going to put the $980,000. This means that what we're trying to find is the tax, which it said, find the tax. So, just going through this, right? We're gonna stick with fish method. We got 1, 2, 3, 4 values. Kind of large numbers. Maybe I should have given myself more space. Okay, but we're gonna go from the X. Okay, so from my X, I'm gonna make the tail of the fish, which is a straight up and down line. In this case, up, and we run into that $980,000 assessed property. Cross back down to make the body of the fish. We run into the $6,300. We'll make the head of the fish, which is going to bring us back up to the $300,000 assessment. And then we'll come back down to the X. So, in your calculator, 980,000 times 6,300 divided by 300,000, and I got an X value that is 20,580. Now the answer is not 20,580 because it's a word problem. Make sure that you label it. Now it's better. If you had a $980,000 property in Moab, you would expect to pay, at least with whatever this tax rate is, $20,580. That's it. Okay, so we got Calvin's Concrete Company supplied a contractor with 18 cubic yards of concrete at a cost of, I forgot I say they, but I mean me. Forgot the dollar sign there. $1,323. Assuming they charge the same rate per cubic yard, regardless of the amount of concrete supplied, what would they charge for 26 cubic yards of concrete? Okay, take a minute, try this one out, and we'll go over it. We know we're going to set up a proportion, okay? So we got two different values. You got 18 cubic yards at this price. We've got 26 cubic yards, but we don't know what that price is. Okay, so I'm going to set up a proportion because you're going to pay the same amount per cubic yard no matter how much concrete is supplied. So that's another way of saying you got equivalent ratios or equivalent rates or equivalent fractions. Now, what I'll do is I'm going to start with let's start with the 18 cubic yards. Okay, now the 18 cubic yards costs $1,323. So this one's a little different because the labels are different. And I'm just going to do this in order. So I'm going to put cubic yards here on the top, and I'll put dollars here on the bottom. Now, if you're going to do that, though, you need to make sure that your other fraction has cubic yards on the top and then dollars on the bottom as well. You can't flip them once you have the labels where they are. So the first ratio that was given was 18 cubic yards for $1,323. If you want to put the decimal, that's okay. The second value says it's going to be 26 cubic yards. So I'll put a 26 for my cubic yards. How do I know that 26 goes here? It's because I already had the label in cubic yards. Okay? And again, this is to make sure that they match. What we don't know is the price. So what would they charge? That's what I don't know, so I can put an X there for my unknown. And now this is set up. This is one of 8 different ways that you can set this up accurately and still get the correct answer. So all we're going to do is plug these values in to the fish method. Multiply, divide, equals. So fish method, I'll start with the X. I'll come up to the 26. There's my 26. Cross back down to the 1323. Swing it back up to 18. And then finish off at X. And again, this is just something I got to put into my calculator. When I put it in there, I got 1,911. Now again, it's not just 1,911. It would be in dollars. And that's it. So if they charge the same amount, no matter how much concrete you got, if you were looking for 26 cubic yards at this rate, it'd cost you $1,911. There's our objective. So that last part, right, we wrote the proportions, and then solving the proportion, we seem to like that fish method, which I do as well.